Welcome to HeyGen Podcast. Today we're diving into the fascinating world of sirtuins and resveratrol. Let's jump right in.
Absolutely. I've been really looking forward to this. So, sirtuins, they're pretty important. But can you explain what they actually are?
Sure thing. Sirtuins are a family of proteins, specifically NAD+ dependent enzymes that act as deacetylases or ADP ribosyl transferases.
Wait, NAD+ dependent? What does that mean exactly?
Well, it means they require nicotinamide adenine dinucleotide, or NAD+, to function. It's like, or rather, NAD+ is the fuel that powers them, you know? This links their activity directly to the cell's metabolic state.
So they're metabolic sensors?
Exactly. And in mammals, we've got 7 sirtuins, SIRT1 through SIRT7, each hanging out in different parts of the cell.
Interesting.
They regulate a bunch of metabolic and stress response pathways.
That's fascinating. So what roles do they play in our bodies?
They do a lot. For starters, they regulate metabolism by influencing the activity of metabolic enzymes and transcription factors. They also play a part in aging and longevity. Increased sirtuin activity is linked to improved cellular stress resistance, DNA repair, and even longer lifespans in some organisms.
Wow, so they're like guardians of the cell?
Yeah, you could say that.
Right.
They suppress inflammatory pathways and protect against oxidative stress, which helps cells survive tough conditions.
That's amazing, but how do they actually work?
So, their main mechanism is deacetylation. They remove acetyl groups from lysine residues on proteins.
Okay.
This affects gene expression, protein function, and signaling pathways.
Can you give an example?
Sure. SIRT1, for instance, deacetylates PGC1A, that's the master regulator of mitochondrial biogenesis, and NFQB, which controls inflammatory responses. So, they have a big impact on how our cells function.
So where does resveratrol come into play?
Great question. Resveratrol is a natural polyphenol found in grapes, red wine, berries, and peanuts.
Interesting.
It's gained attention because it can activate sirtuins, particularly SIRT1.
Oh, so drinking red wine is good for you?
Well, in moderation. But you'd need to drink a barrel to get enough resveratrol from wine alone.
Right, so resveratrol activates sirtuins. What does that do for us?
Activating sirtuins with resveratrol can improve metabolic efficiency by enhancing mitochondrial function and fatty acid oxidation. It also has anti-inflammatory effects and boosts cellular defenses against oxidative stress.
That's impressive. Has this been proven in studies?
Yes, in many preclinical studies and animal models, resveratrol extended lifespan and improved metabolic health. For example, in rodents, it improved insulin sensitivity and protected against heart disease.
That's promising. But what about humans?
In humans, the results are, mixed. Some clinical trials show modest improvements in metabolic parameters like blood glucose and lipid profiles, but the effects aren't as dramatic as in animals.
Why do you think that is?
One of the challenges is resveratrol's low bioavailability. It's rapidly metabolized and excreted, so it's hard to achieve therapeutic levels in humans.
So dosing is a problem?
Exactly. Determining the right dosage without causing side effects is tricky.
Right.
Researchers are working on formulations to improve its absorption and efficacy.
That's good to hear. Are there other challenges?
Definitely. Translating findings from animal models to humans is complex. Our metabolism and physiology are different, and some studies have conflicting results.
So it's not a magic bullet then?
No, it's not, but it's a promising area of research.
You know, I wonder if focusing solely on resveratrol is the best approach.
That's a great point. Researchers are looking beyond resveratrol to develop more potent sirtuin activators.
Interesting.
There are synthetic compounds in development that might be more effective.
And what about combining treatments?
Yes. Combining sirtuin activators with other metabolic or anti-inflammatory agents could enhance therapeutic outcomes. It's like, tackling a multifaceted problem with a toolbox instead of just one tool.
Personalized medicine might play a role here too.
Absolutely. By identifying biomarkers to predict how individuals respond to sirtuin modulation, we can tailor treatments to maximize benefits and minimize risks.
That's exciting, but we still have a long way to go, don't we?
We do, but the future looks promising.
Agreed.
With ongoing research, we might unlock the full potential of sirtuins and resveratrol in improving human health.
Let's hope so. It's like we're on the brink of a breakthrough, isn't it?
Yeah, exactly. It's an exciting time in biomedical research.
Well, thanks for shedding light on this topic. I learned a lot today.
My pleasure. It's always
Absolutely.
great to discuss such fascinating science.